Today we'll be learning about finding the polynomial equation given its zeros. So we will work with three problems, and let's start with this one. So we have a polynomial with a degree 4, and the zeros that we have are 1, -1, 3, and 5. Now remember that if we write our equation in factored form, we can get the zeros as x minus a, x minus b, and x minus c, and so on, given that a, b, and c are the zeros. So that means that we can write this as x minus 1 multiplied to x minus minus 1 times x minus 3 times x minus 5. So let's simplify this equation, and that will be x minus 1, x plus 1, x minus 3, and x minus 5. Now we can begin with multiplying the first two factors, so that would be x squared minus x plus 1 minus 1 rather, and then the last two, which is x squared minus 5x minus 3x plus 15. After that, we can simplify this. So the first one, that would just be x squared minus 1 because the x's cancelled out, and then x squared minus 8x plus 15. Now we can use the distribution to work on the last two values. So that would be x raised to 4 minus 8x cubed plus 15x squared minus x squared plus 8x minus 15. And then we can just combine the similar terms on our equation. So that will be x raised to 4 minus 8x cubed plus 14x squared plus 8x minus 15. Okay, so this will be our polynomial with the zeros 1, -1, 3, and 5. Okay, so let's try another one, and we have a polynomial with the degree 3 and zeros 3 and -2i. So there are only two given zeros, but remember that on the conjugate root theorem, it says that if we have one imaginary root, then it's automatic that they come in pairs. So that means that if we have -2i, we also have +2i. So our zeros will be 3, -2i, and 2i. Now we'll just do the same thing that we did with the problem earlier. We can just multiply these in factored form. So that's x minus 3, x minus -2i, x minus 2i. So the second term will be x minus 3, and then that becomes x plus 2i, then x minus 2i. Okay, so for this one, let's simplify the last two terms. So that would be x squared minus 2ix plus 2ix minus 4i squared. So we just used FOIL there. Now the middle terms cancelled out. So we will have x minus 3 multiplied to x squared minus 4. So I squared is -1. So we can replace it with -1. So that's x minus 3 times x squared plus 4. And then we can just use FOIL again. So that's x cubed plus 4x minus 3x squared minus 12. If we simplify this, if we put the terms in descending order, that would be x cubed minus 3x squared plus 4x minus 12. So this will be our polynomial with the degree 3 and zeros 3 and -2i. Okay, so for our last example, we have a polynomial with a degree 5, and our zeros are 1, 1 plus I, and I. So we mentioned earlier that the conjugate root theorem says that the zeros always comes in pairs if they are imaginary. So that's 1, 1 plus I, 1 minus I, I and negative I. So if we put that in factored form, that would be x minus 1 times x minus 1 plus I plus 1, x minus I minus 1 minus I, x minus I, and x minus minus I. If we simplify this one by distributing the negative signs, that would be x minus 1, x minus 1 minus I. So that's x minus 1 plus I, x minus I, and x plus I. After that, we can simplify these by multiplying them by pairs. So let's begin with x minus I and x plus I. So using FOIL, that would just be x squared plus ix minus ix minus I squared. So the middle terms zeroes out, so that's x squared minus I squared. And we know that I squared is negative 1, so that's x squared minus negative 1, or x squared plus 1. Now let's try the other two imaginary roots, so we can just use the distributive property. So let's begin with x. That would be x squared minus x minus ix minus x plus 1 plus ix plus ix minus I squared. So the two ix zeroes out, and that's the same thing for I and negative I. So we will have x squared minus 2x plus 1 minus I squared. But I squared is negative 1, so we can rewrite it as x squared minus 2x plus 2. Now let's work on our expanded equation. So that's x minus 1, x squared minus 2x plus 2, and x squared plus 1. We can begin with multiplying two of these factors. So that will be x cubed minus 2x squared plus 2x minus x squared plus 2x minus 2 multiplied to x squared plus 1. So if we simplify this by combining the similar terms, that is x cubed minus 3x squared plus 4x minus 2 multiplied to x squared plus 1. Now we can distribute these again. So that will be x raised to 5 minus 3x raised to 4 plus 4x cubed minus 2x squared plus x cubed minus 3x squared plus 4x minus 2. Now I can just combine the similar terms here. So that's x raised to 5 minus 3x raised to 4. That's 4x squared plus x cubed rather. So that's 5x cubed, and then negative 2x squared minus 3x squared is negative 5x squared, 4x minus 2. So that will be our resulting polynomial equation, given that our zeros are 1, 1 plus I, 1 minus I, and negative I with a degree of 5.